All right, y'all. Very last thing we're going to be talking about absolute value functions is writing absolute value equations. Now, writing absolute value equations is usually pretty straightforward. You just want to kind of identify what that original or what that target value is, and then how I'm trying to shift off or shift away from it. So the situation we're looking at is the official rules of baseball state that all baseballs used during professional games must be within a specified range of weights, and the baseball manufacturer sets the target weight of the balls at 145.045 grams on its machines. And we know a sketch a model that models a relationship between a manufactured baseball's weight, X, and its distance from the target weight, Y. So on this graph, let's go ahead and put that target weight of 145.045. And that target weight is going to be our starting point for our absolute value function. So we're going to put a point right here about 145. It's technically a little bigger, but it's so minuscule it would be about there. Okay. Then for our baseballs, they don't tell us anything about the manufacturing, if they manufacture, if they're all vastly different or if they all just differ by the amount of weight difference that comes off of that 145. So we can assume that the absolute value function that this represents would just go up by 1 as the manufacturer baseball weight goes up by 1. And so that weight difference, how far it is off of that manufacturer weight, would also go up by 1. So it should look like our parent absolute value function. And likewise in the other direction, if our manufactured weight was a little bit less, then it would of course differ in that same positive direction, which creates that absolute value function. Okay, so we can see our absolute value function here. We have it sketched out, but now we want to write an actual equation to represent this. Okay, and looking at this absolute value function, so it still has that slope of 1, so our A and our B should still be 1. We don't have any vertical stretch compressions or horizontal stretch or compressions. Okay, our vertex is right on the x-axis, so we're not shifting up or down. The only thing that our function has done is that it's shifted to the right by 145.045. So to shift to the right, that's going to be our C value. So we can write our absolute value function as Y, which represents the difference in weight, is equal to the absolute value of X, which is the actual manufactured baseball weight, minus that expected weight that we want, which is that 145.045. And remember, it is minus because C is always opposite, so that negative C value in the equation is going to shift us right on the actual graph. Okay. Now in part B, they tell us that the specified weight allows for a difference of 2.95 grams in the actual weight of a ball and the target weight. Since the weight must be within a distance of 3.295 grams from the target weight, Y equals 3.295. So they've given us a second equation to add to our graph, specifically that our Y value needs to be no higher than 3.295. So we're going to go on to our lovely graph, and just a little bit higher than 3 because it's about 3.3. We'll graph a nice straight horizontal line to represent that Y equals 3.295. Okay. And in part B, we want to think about two different equations or inequalities that we could write that would represent this in between. And we want it to be less than that weight difference of 3.295. So we don't want greater than, we want less than. So less than 3.295 to the left, so a little bit less than our 145 would end at this point. And then it could be greater than 145, but no greater than this point over on the other side of our graph. So use your calculator real quick, okay, to calculate from 145, how much higher it can be using that 3.295, and how much lower they can be using that 3.295. All right, y'all. Hopefully you got that 148.34 as that maximum weight and 141.75 as that lowest weight. Okay, so when comparing the two, our X value, our manufactured weight, has to be less than that 148.34 while greater than that 141.75. So X would be less than 148.34 or X must be greater than 141.75. It does say within the distance 3.295, so I would assume that we could include that exact weight of 148.34 and 141.75. So we'd want to add those equals to's. Okay. Now, the very last thing that we want to do is write this as one complete solution because these are still two separate equations. So because we're greater than 141 but less than 148, we can do that as a compound inequality. 141.75 is less than or equal to X, which is less than or equal to 148.34. All right. And y'all, that's really all there is to writing absolute value equations. They're typically rather straightforward. Most of the situations are the same. There's a bit more practice in our 1A.3 to 1A.4 practice packet, as well as the review packet you're going to pick up in class.